Let's keep doing some problems. So in the last time I said, what are the chances of getting not getting any heads if I flip the coin? I was going to say dice, but I realized we're dealing with a coin. If we flip the coin 7 times, and we said, well, that's the same thing as getting 7 tails in a row, and that's 1/2 to the 7th power, right? Because each trial there's a 1/2 of getting the exact same, a 1/2 chance of getting the exact thing that we want, which in this case is tails. And you multiply it times itself 7 times, and you get 1/128. And it actually turns out that there are actually 1/128 possible results that we can get, equally probable results. And why do I say that? Well, what's the probability? What's the probability of getting, I don't know, all heads, and then the last flip I get is tails? So heads, 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 heads. So I'm doing it 7 times, right? It's 1, 2, 3, 4, 5, 6, and then the last time I get a tails. Right? Well, this is, if you can think of it, this is exactly one particular result out of the total results that we could get. And what's the probability of this? Well, there's a 1/2 chance of getting a heads, 1/2 chance of a heads, 1/2 chance of a heads. Let me switch colors. 1/2 chance of a heads, 1/2 chance of a heads, 1/2 chance of a heads, and then 1/2 chance of a tails. But once again, this is just 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is equal to 1/128. So any particular, I don't want to say combination because we'll learn a little bit about permutations and combinations in future videos, but any particular set of circumstances we want is 1/128 of the total number of outcomes. That's what I should use instead of circumstances, outcomes. If I have any particular outcome, so this is a particular outcome. Well, the way to view it is there are 128 particular outcomes. So if I choose one of them, my odds of getting it is 1/128. So let me ask you a question. What's the probability of getting exactly 1 heads? What's the probability of getting exactly 1 heads? So what does this mean? This means I could get tails, tails, tail, and let's say we're doing it 5 times, just so I don't waste too much time. Out of 5 rolls, out of 5 flips, out of 5 flips. So that could be tails, tails, heads. That could be, as you can tell, I switch colors arbitrarily. That could be tails, 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 head, tails. Right? I think you get the pattern. Tails, tails, heads, tails, tails. That could be tails, heads, tails, tails, tails. That could be that could be heads, tails, tails, tails. So if we look at it this way, there's this probability. There's actually how many events, how many outcomes would satisfy the statement exactly 1 heads? Well, there's 1, 2, 3, 4, 5. And the way you could think of it is we're going to do 5 flips. Exactly one of the flips is going to be heads. It could be any one of those 5 flips. So there are 5 situations in which that happens. And I notice I said exactly 1 heads, because if I said at least 1 heads, then we would have to take into the circumstances where we have 2 heads, and then it becomes more complicated. And we'll learn more about that when we do combinations. So what are the chances of any one of these possible outcomes? Well, if we just look at this one, there's a chance of 1/2, 1/2, 1/2, 1/2, 1/2. So it's 1/2 to the 5th power, which is equal to 1/32. And you use the same logic. Each of these, this is 1/32, 1/32, 1/32, 1/32. And in general, when I'm flipping a fair coin 5 times in a row, there are going to be 32 possible outcomes. And each of these is just one of the particular outcome. And we're essentially saying out of the 32 outcomes, 5 satisfy the event that we're looking for. Exactly 1 heads out of 5 flips. So there are 5 that satisfy it out of a total of 32 outcomes. And so using that definition, only if we can say that all of the outcomes are equally probable, the probability is 5/32. And then you could say, well, let me make it a little bit more complicated. What is the probability of not getting exactly one head. So here there's a lot more circumstances that satisfy it. So for example, let me throw out a couple that would satisfy it. Well, you could get all tails. You could get all tails. But also, if you got two heads, that would satisfy because you didn't get exactly one head. So this would also satisfy it, right? And so you might say, well, if we do it like this, it's really complicated. Or you could say, well, these 5 over 32 are the only outcomes that don't satisfy, that do not satisfy this condition. So the rest of the 30 of what 32 minus 5 is what 27. The other 27 outcomes will satisfy this. So you could say that this is equal to, and this is a common trick in a lot of probability problems, this is equal to 1 minus the probability of it getting exactly 1 heads out of 5 flips. And that is equal to, 1 is the same thing as 32 over 32 minus, what's the probability of this? Well, we figured it out. It's 5 over 32. And that equals 27 over 32. So that's just always something to keep in mind. Sometimes when you get a probability problem, it seems difficult to solve that problem, but it's actually not that difficult to solve the opposite problem. So you say, well, it's hard for me to directly figure out the probability of not getting exactly 1 heads. I'd have to know combinations, all of this. But this is the opposite of getting exactly 1 heads, and that's an easier thing for me to figure out. So if I can figure out that probability, all of the other outcomes would satisfy the opposite one. Hope I didn't confuse you. So anyway, everything we've done so far, it's been dealing with coins and fair coins, and that's that's interesting to a certain degree. But let's make it so that the different outcomes have different probabilities. So let's do free throw percentages, because I think this is something that we all, if we watch basketball or play at all any basketball, we're familiar with the idea. So let's say that and this is not true, I only could wish. Let's say that I have an 80% free throw percentage. So that means every time I go to take a free throw, there's a 80% chance there's a basket, and that there's a 20% chance there's no basket. And how has this come up with? Well, we'll do more on statistics later, and they're really, probability and statistics are opposite sides of the same, I guess, coin, you could say. But someone says, okay, out of the last 100 times Sal took free throws, he's made 80. So in general, he has an 80% chance of making a particular free throw. But it might not have been 100. I might have taken 1,000 free throws and I made 800. But that's where you come up with the 80% from. So that's fair enough. So we could call that, so the 80% is P. And then a common notation is the 20% is 1 minus P, right? If I have an 80% chance of making the shot, I have a 20% chance of missing the shot, right? So my question to you, let's do kind of the same examples we did with the coins. What's the probability of me making, I don't know, 3 shots in a row, 3 baskets in a row, or 3 free throws in a row? Let me say free throws, because this is my free throw percentage, not my overall shot percentage. Well, by the same logic, it's going to be equal. I would have to get 80. The first one I have to get right. Then the second one I would have to get right. I would have to get a basket, and not, there's a 20%. I have no basket. And then the third one I would have an 80% chance, right, of getting a basket. So this is, I didn't draw the rest of the tree, right? It gets pretty broad. But in general, just from the coin example, you can just multiply these probabilities, right? So then you get, so 80% is the same thing as 0.8. So we get 0.8 to the 3rd power. And I don't know, what is that? Let me see. It is 0.8 times 0.8 times 0.8 is equal to 51.2, or 0.512. 51.2% is equal to 0.512, which is equal to 51.2%. So I have slightly better than even odds of making 3 free throws in a row, which is pretty good. And as you can see, I don't have an exponent on this cheapo Windows provided calculator I use, so I have to apologize for that. So we might have to limit our exponent size. But anyway, that should hopefully, well, that's a little bit of a taste. In the next video, I'll do a lot more examples with the free throws and the basket, and we'll even learn a little bit about conditional probability. See you soon.